An, an inextensible heavy chain lies in a smooth horizontal plane. An impulsive force is applied to A, requires the initial motion of K. Let ds be the infinitesimal link, of which for the present we've only to think. Let t be the tension and t plus dt, the same for the end that is nearest to B. Let a be put by a common convention. For the angle at M, twist OX and the tension. Let B sub t and V sub n be the s's velocities, of which V sub t along and V sub n across it is. Then V sub n quotient V sub t, the tangent will equal of the angle of starting worked out in the sequel. In working the problem, the first thing of course is to equate the impressed and intellectual forces. K is tuned by two tensions, whose difference dt must equal the element's mass into V sub t. V sub n must be due to the force perpendicular to ds's direction, which shows the particular advantage of using the A to serve at your leisure to estimate ds's curvature. For V sub n into mass of a unit of chain must equal the curvature into the strain. Thus, managing cause and effect to discriminate, the student must fruitlessly try to eliminate and painfully learn that in order to do it, he must find the equation of continuity. The reason is this, that the tough little element which the force of impulsion to beat to a jelly mint was endowed with a property incompressible, and was given, in the language of shop, inextensible. If therefore with such pertinacity outdefied, the force which the length of the chain should have modified, that its stubborn example may possible yet recall, these overground rhymes to their propositi metrical. The condition is got by resolving again, according to x's assumed in the plane. If then you reduce to the tangent and normal, you will find the equation more neat, thus less formal. The condition thus found after these preparations, when duly combined with the former equations, will give you another in which differentials, when the chain forms a circle, become inessentials, no harder than those that we easily solve in the time t totum would take to revolve, now joyfully leaving the s to itself at t tend to the value of t and of a. The chain undergoes a distorting convulsion produced first by a by the force of impulsion, in magnitude r, in direction tangential, equating this r to the form exponential, obtained for the tension when a is 0. It will measure the tug, such a tug as the hero, plume waving, experience tied to the chariot, but when dragged by the heels his grim head could not carry off. So give A its due at the end of the chain, and the tension ought there to be 0 again. For these two conditions we get three equations, which serve to determine the proper relations between the first impulse and each coefficient in the form of the tension, and this is sufficient to work out the problem, and then, if you choose, you may turn it and twist it the don'ts to amuse. James Clerk Maxwell.